Section 7.3, Example 3 on page 453. When numerical expressions have the same value, you say that they are equal. Similarly, if two segments have the same length, then the segments are congruent segments. The congruent symbol is very similar to an equal sign, we just have this extra curve above. This means that if the length of segment AB is equal to the length of segment CD, then segment AB is congruent to segment CD. You can also say that if segment AB is congruent to segment CD, then the length of segment AB is equal to the length of segment CD. So here we have a line segment, AB, which is 1 inch in length, and a line segment CD, which has a length of 1 inch as well. Therefore, segment AB is congruent to segment CD. We show this by using a tick mark. Over here, we have the length of segment AB equals the length of segment CD because they are both 1 inch. This implies that segment AB is congruent to segment CD. As illustrated above, you can mark segments alike to show that they are congruent. If there is more than one set of congruent segments, you can indicate each set with the same number of marks. For example 3, we have our segment AC and segment BD congruent. Like the previous problem, we can actually check the lengths of segments AC and BD by using the number line. So again, this number line is counting by 2. So instead of making one bubble count as 2, I just put 2 bubbles in between each tick mark. So we have 1, 2, 3, 4, 5, 6, 7 bubbles between point A and point C. So the length of segment AC is 7. And then from B to D, we have 1, 2, 3, 4, 5, 6, 7 bubbles again. So the length of segment BD is also 7. Thus, we have the length of segment AC is 7, the length of segment BD is 7, and 7 equals 7. So the length of segment AC equals the length of segment BD, which implies that segment AC is congruent to segment BD. You could also use the formula to figure out the length of each segment, but you are also welcome to just use the bubbles on the number line. The work for this problem is written out on the next few slides, and you can see that to find the length of segment AC, they use the definition of distance. So again, you can use the absolute value of coordinate A minus coordinate C, or you can count on the number line. Now I would like you to try number 5 and 6 on page 454. Use the number line below for exercises 5 and 6. Tell whether the segments are congruent. For number 5, we have segment LN and segment MQ. For number 6, we have segment MP and segment NQ.